Hi, in this video, we want to look at the determinant of a matrix, how to find the determinant of a matrix. Earlier on, we talked about the multiplication of matrices. We've talked about the addition and subtraction of matrices. We've talked about different types of matrices that we have. And in this video, we'll be looking at the determinant of a matrix. Now, determinant of a matrix is actually a very important topic because if you're able to find the determinant of any matrix, and definitely one of its application is in finding the area of the triangle, is in finding the inverse of a matrix. We also use it in finding or solving questions on simultaneous equation. So if we want to use the method of matrices to solve a system of linear simultaneous equations, then definitely you must definitely know how to find the determinant of a matrix. So it's important, it can't be overstated. Now, what does it mean, or how do we find the determinant of a matrix? So let's say we're given a matrix A, and then we're told that A is equal to 4, 2, 5, and then 3. Okay. Now, if we want to find the determinant of this matrix, so of course it has its notation, so we can okay, the determinant of matrix A, we write it inside of two vertical lines. So of course this looks like maybe writing absolute value or modulus, but it's not the same thing, or it doesn't have the same meaning. This is just determinant. So we can also write it as determinant of A or delta A. So whichever one you see in your text or textbook, don't be alarmed. It means the same thing. So to find the determinant of a 2 by 2 matrix. Now, before I even move on, we should note that we can only find the determinant of a square matrix. We can't find the determinant of a rectangular matrix. I remember we said a square matrix is a matrix that has equal number of rows and column. Like the order of this matrix has 2 rows and 2 columns. You can't find the determinant of a rectangular matrix. It is not possible. So now moving on. To find the determinant of a 2 by 2 matrix, you simply want to multiply the diagonals together and subtract them from each other. So we have two diagonals. We have the leading diagonal, which is 4 and 3, and then we have the backward diagonal, 5 and 2. So multiply 4 and 3 together, multiply 2 and 5 together, and subtract them from each other. Of course, since we're talking about subtraction, order matters. So the leading diagonal has to be first, and subtracted with the backward diagonal. So what do we mean? So for the determinant here, we simply say 4 times 3, okay, minus 5 times 2, and then we simplify. 4 times 3, we're having 12, minus 5 times 2, we're having 10, and 12 minus 10, so yeah, we're having 2. So the determinant of this matrix A is equal to 2. Earlier, when we were talking about the transpose of a matrix, we talked about different types of matrices, where we talk about the transpose of a matrix. Now, if we were to transpose this matrix A and find its determinant, so let's say matrix A transpose, so we'll be having 2, so I said 2, sorry about that, so we'll be having 4, 2, 5, 3. And if you were to find the determinant to be exactly equal to 2, exactly equal to 2. So a matrix A and its transpose will definitely have the same determinant. So, okay, so let's look at this. So here we have, so again, 4 times 3, okay, and then here we have minus 5 times 2. So this is equal to 12 minus 10, and then you are still having 2. So you can see that to find the determinant of a 2 by 2 matrix is quite easy. And then an important property you should know is matrix A and A transpose will have the same determinant. Okay, so now let's look at how to find determinant of a 3 by 3 matrix. So what if we're given a 3 by 3 matrix, and then we have to find the determinant of a 3 by 3 matrix. Okay, so let's say we are given matrix A to be equal to, so here we have 1 minus 2, 3 minus 1, 3, 1, 2 minus 1, and 2. Okay, so and then we're asked to find the determinant of this matrix. So basically what we want to do for this one is simply to take the first row, and then we're going to be doing the summation of the product of the minus of the first row, and then we multiply them with their cofactors. Of course, we've not talked about cofactors now. We'll talk about it in our next video. But just know that when we're looking for the determinant of a 3 by 3 matrix, we take the first row, each element of the first row, that is 1 minus 2 and 3. So for 1, I'll multiply one with its minor and its cofactor also. So what do I mean? So remember, we were to write matrix A according to its unique identifier. So if I want to represent the elements uniquely, so one will have a unique identifier of A11, A12, A13, then minus one, A21, A22, A23, A31, A32, A33. Okay. For determinants of a 3 by 3 matrix, I only need this first row. So just the first row. In our next video, we'll look at everything, all the members, all the elements of this matrix when we talk about the cofactors. But for this one, we only need the members of the first row for a 3 by 3 matrix. Now we take the first member, A11. So A11, 1. Then we said we multiply the minors together. So the minor of A11 is simply we taking the first row, like we're striking, because A11 belongs to the first row. A11 belongs to the first column also. So we strike out the first row, strike out the first column. I'll be left with A22, A23, A32, A33. So in such a way that will have something like this. So I have a big bracket. So first of all, multiply by its cofactor minus 1. You can see this is 1 and 1. So add them together, this is 2. So that will constitute the power here. So times again, what do I have inside of this? I have A22, A33. So do the product. So A22 dot A33, then subtract, okay, minus, okay. Uh, what's this one? A32 dot A23. So this is what we are trying to say. So you're multiplying its cofactor by its minor, and then you're summing everything together to get you what's it called, the first member that's here. So of course we're still going to add them. That's why I said the summation of the product of what we're having here. So we get that for A11, we get for A12, we get for A13. So let's just write the A12 formula. So for A12 again, we do the same thing, minus 1, then the power. So 1 plus 2 gives us 3. So dot, open my brackets. Now if I strike out A12 belongs to the first row and second column. So strike out the first row, strike out the second column. What am I left with? A21, A33, A31, A23. So this gives me A21 dot A33 minus A31 dot A23, and then I'm done with A12. Okay. Then lastly, A13. So again, do the same thing. So minus 1, 3 plus 1, that's 4, dot A21, okay, so I said A21, so that's because I saw A21 here. So again, what do we do? Strike out the first row, strike out the third column. So I'm left with A21, A32. So again, A21 dot A32, okay, minus A31 dot A22. So this is how we want to find determinant of this matrix. After we've gotten A11, A12, and A13, then we add them together, or we'll do a summation of all of them together. So let's just do it beside it. Now we're going to be doing another example. In fact, we'll do about 2 more examples, and then I'll be showing us a shortcut to solving or to finding determinants of the 3 by 3 matrix, in case you don't want to use this long process. But for the second example, when solving the second example, we won't be writing all these things down. So you're expected to know them. So the reason for this negative one is just to assign the signs for these guys. You can see this is minus 1 to the power of 2. So if you square a negative number, it returns a positive value. If it, what's it called? If you cube a negative number, it returns a negative value. So in as much as the power of the negative number is even, then it always returns a positive value. If the power of the negative number is odd, it will return a negative value. So this negative one is just to assign the signs, or to put the signs of our determinants there. So what sign A11 will carry, what A12 will carry, and what A13 would carry. And then this minus, we only use them to ensure that we were able to find the determinant of the said matrices. So let's get the value of A11. So from this matrix A, remember A11 is 1, isn't it? So I have 1 in the bracket of of course this minus 1. So because we already, okay, so let me just write it so not to confuse anyone. So minus 1 squared, okay, dot, then A22 times A23. So where's my A22 times A23? A33 rather. A22 times A33, that's 3 times 2. So that's 6. Okay. 6 minus, where's this other one? A32 times A23. A3 2 times A2 3. So 3 2 minus 1 times minus 1. So that's minus 1. So 6 minus minus 1, that becomes 6 plus 1. So and then this is what we have, those are brackets. So 6 plus 1, that's 7. 7 times 1, 7. So everything here would be 7 for the first one. So for the second one, what do we have? A12 again. So write, so what's my A12? My A12 is negative 2. So write my negative 2 there. Then minus 1 to the power of 3. So of course this will return a negative value. That's negative 1 to the power of 3. And then let's try and multiply what we're having. So 81 times 833. So minus 1 times 2. So that gives me minus 2. This minus 1 times 2. Remember, we've written it here, 821 times 833. 821 times 833. How do we know it is 821 times 833? We're picking negative 2 now. So strike out this first row, strike out this first column. So minus 1, 2, 2, and 1 are the minus that we're having. So subtracted from, again, 2 times 1. So that's 2. So 2 times 1 is 2. Again, close this bracket and this. So let's simplify. Minus 2 minus 2. That's minus 4. Minus 4 minus 1. So that's plus 4. Plus 4 times minus 2. So that's equal to negative 8. Okay. And then lastly, for A13, so what's my A13? So we have 3 here. Okay. And then minus 1 in the bracket of 3. Okay. And then we have dots. Okay. Okay. This should be 4, not 3. Okay. So what's my A21? A21 is minus 1 times A32. So minus 1 times minus 1. So that will give us positive 1 minus 3 times 2, so that's 6. Okay, so this is 1 minus 6. 1 minus 6, that's minus 5. Minus 5 times positive 1, still minus 5 times 3, so that's negative 15 minus 15. So my determinant will simply be equal to 7 minus 8 minus 15. And 7 minus 8, that's minus 1. My determinant is negative 16. So negative 16. Now, is this the only way to solve this question? Definitely no. There's a shorter method. Of course, this one only appeared to be longer because I had to write down the unique identifiers and show you what exactly we are doing. In the next question, it won't be this messy. So we'll just go straight to the point. But we're saying there's another shortcut in solving, what's it called? In solving or finding the determinant of a 3 by 3 matrix. Okay, so let's quickly do that one. So let's note our answer here. So the answer we're having here is negative 16. Okay, so let me just do this. Negative 16. Okay, so let me clear this part here and we'll see how we can. Okay, all right, so in order to use the shortcut, like we said, so you want to write the matrix itself back. So write it in such a way like this. So 1 minus 1 2 minus 2 3 minus 1 and then 3 1 and 2. Now after writing this, before you close the matrix or before you close the bracket, you want to write the first two rows. Just write it in continuity like this: 1 minus 1 2, then minus 2 3 and minus 1. So that's what I've written. I wrote the original matrix itself, and then I added the first two columns, not rows now, first two columns to the matrix itself. So the next thing to do is to multiply the diagonals. Multiply the diagonals. What do I mean? So look at this arrow. So 1 times 3 times 2. So add it with minus 2 times 1 times 2. Add it with minus 3 times minus 1 times minus 1. So when we're done with this, then we want to multiply it again or subtract it from the what's it called, from the backward diagonal. So we'll do something like this. We'll do something like this. So that is 2 times 3 times 3. Again, we'll do something like this. We'll do something like this. And then we'll do something like this. And then we'll do something like this. So the one with the red and this thing, so we're subtracting it with the one with the blue ink. Okay, so quickly, let's just see what we're doing. So this time around, there's no point writing the length value. So we'll just be multiplying directly. So remember this red arrow, we're multiplying. So 1 times 3 times 2. So 3 times 2 is 6 times 1. So that's 6 plus, again, the next red one. So 2 times minus 2 times 1. So remember this will be negative 4. Okay. Then lastly, 3 times minus 1 times minus 1. So that will be plus 3, isn't it? Then subtract it with the blue this thing. So 2 times 3 times 3. So 3 times 3, that's 9. 9 times 2, that's 18. Okay, of course, you add the blue ones together. So 1 times 2, this is minus 1. Okay. And then lastly, minus 2 times minus 1, that's 2, times 2, that's 4. So this is 4 plus 4, rather. Okay. All right. So now we want to simplify. So 6 minus 4, that's 2. 2 plus 3, we have 5 here, minus 4 times 4 minus 1. 4 minus 1 is or 1 minus 1 plus 4, rather. So minus 1 plus 4, or 4 minus 1, rather, that's 3. Okay, so 18 plus 3, that should be 21. So we have 5 minus 21, and 5 minus 21 just gives us minus 16. So just like the way we did, got our negative 16 in the first place. So you can see that, like, of course, if you encounter a question on finding determinants of a 3 by 3 matrix and it is not a theory written question, then you can simply use the short method to quickly find that. But if it is what's it called, a theory based exam, then definitely you want to use the what's it called, you want to use the proper method in solving the determinant of a 3 by 3 matrix. So let's just do one more example using the first method, not this shortcut now. So use the first method, but the shorter version of the first method, just in case it was confusing when we did it at first. So, but this time around, we won't be writing too many information on the screen, so as not to confuse you more than intended. Okay, so we have -5, we have 2, we have -8, we have -10, we have 1, we have -4, we have 10, we have 2 and 7. So again, now using the short method, just assign these place values plus, minus, plus, like it will always be like this. Don't worry about that. Then what you want to do is bring out the first element or the first one, so -5, then bring out this one, then multiply this diagonal together. So we have 1 times 7, that's 7. Then 2 times -4 is -6. So 7 minus -6. So you can see what we've done. Okay. Then close this. Then you can see that this sign here is negative. So write the negative here. So 2. Okay. Again, open the bracket. And then what do we have? Strike out this. Strike out this. So we have -10 times 7. So that's -70. Okay. -70. Then 10 times -4. So that's -40. Okay. We have, again, close the brackets. And lastly, to write our sign plus. Of course, 8 is negative. So you can see what I'm doing. And then we have this. So strike out this. Strike out this. So 10 times 2, or -10 times 2. So that's -20. Okay, and 10 times 1 -10. So if we simplify this, we'll be having our answer. So 7 plus 6. So that's 13. And 13 times -5. So that should give us 65. So 65 minus 65. Okay. Minus, okay. Minus this, and so this is -30. Isn't it? Okay. Negative, negative, that's positive. Okay, so that's -30. -30 times -2, so that's plus 60. And lastly, -20 minus 10, so that's -30. -30 times 8, so that's 240. A little bit negative, yeah, or positive. So plus 240. Okay, so 65. So that's -5. So I think our answer is 235. So you can see that what's it called? The long method, or the first method, is initially not long, because we had to write all the place values first. So that's why it is looking like that. So let's try and quickly use the second method and see whether we arrive at the same answer, 235. So if we can arrive at the same answer, then definitely we've not done this decent job, and then we've not made any errors in the course of our solution. Okay, so again, we're using the second method. -5 minus 10, 10, 2, 1, 2, -8, -4, 7. So we're going to write the first two columns. So -5, -10, 10, 2, 1, 2. Okay, so write this. Then multiply the leading diagonal. So like that is like this. Multiply this with this. So this one with this, like this, and this with this, like this. Okay, so in such a way that we have, so that would be -5 times 1 times 7. So that would just be -35. -5 times 1 times 7, -35. Okay, so 2 times -4, that's -8 times 10. So that's -80. Okay, -8 times -10, that's 80 times 2, that's 160, plus 160. Okay, so everything in brackets, and then minus, so again multiply the backward diagonal. So 10 times 1 times minus 8, so that's again minus 80 plus, okay, 2 times minus 4, minus 4 times minus 5, that's 20. 20 times 2, that's 40. Okay, and then 7 times minus 10, 7 times minus 10, that's minus 70. So 70 times 2, that's 140. So sorry about this. So that should be minus 140. All right, so let's simplify this. So let's just get the calculator. Okay, so we have minus 35 minus 80 plus 160. So everything here will give us 45 minus, okay, so let's simplify this equation here. So we have minus 80 plus 40 minus 140. So we're having minus 180. So 45, 5 minus minus 180. So we're having 225. So I think that's the same answer we got earlier on, or 235. So it was 235. That means we made an error. So when we were doing the simplification, so maybe the addition or whatever, so but the answer we should be having should be 225 and not 235. All right, so this is all we have for the sake of this video. Determinants of a 2 by 2 and 3 by 3 matrix. We've been able to look at different methods to finding determinants of the 3 by 3 matrix. All right, so do well to like the video, share the video, and also subscribe to the channel. Thank you for watching, and bye bye.